Hello everyone, it's a pleasure meeting you all in my mathematics class. I continue with finding the partial derivatives of a given function and proving results, whatever we asked in the problem. Now here you are given z is equal to x squared tan minus 1 of y by x minus y squared tan minus 1 of x by y, and we have to prove the result, namely dou squared z by dou x dou y is equal to x squared minus y squared divided by x squared plus y squared. And understand that this is z is a function of xy. See, z is a function of xy, and that dou squared z by dou x dou y, it means that you are finding the second derivative of z with respect to y and then with respect to x. But even if you do it as dou squared by z by dou x, dou by dou x, you will get the result because commutativity holds good in the case of this. That is, dou squared z by both are equal. That is, your z xy is equal to zyx. So this holds good. Yes, z of xy is equal to z of yx. That is, dou squared by dou x dou y is equal to dou squared z by dou y dou x. Both are equal. But here in this problem you are asked to prove this. So as per this, I will go for finding the derivative of z, partial derivative of z with respect to y, and then find the partial derivative of and find the partial derivative again with respect to x. That is what I will do. Okay, now this is your given. You call this as a, some number a, some 1, we will call it as 1. Now differentiate this with respect to y now. Now I will apply UV, product method, that is UV, that is you keep this x squared as a constant, differentiate this, then keep this as a constant, differentiate this. That is your product rule. When you use the product rule, as per this, you are going to differentiate only with respect to y. Therefore, this x squared must be treated as a constant. Okay. Therefore, x squared into derivative of tan minus y by x partially with respect to y. The immediate derivative of this tan minus of y by x is 1 by 1 plus y squared by x squared. Into, you have to differentiate this y by x. When you differentiate this y by x, as I told you, 1 by x is treated as a constant. And you are differentiating y with respect to itself, that is 1. Therefore, you get x squared into 1 by of this into 1 by x minus, see, this is y squared, so I differentiate this UV method, again product rule. Therefore, 2y into tan minus 1 of x by y. Then this minus is there, therefore when you take it inside, it will be plus into minus this minus this y squared into derivative of tan minus 1 of x by y. That is 1 by, see, same as this, same as this. This is, yes, and tan 1 by x squared plus y squared into, you are going to differentiate this x by y with respect to y. Therefore, treat this x as a constant. Differentiation of 1 by y, see, differentiation of 1 by y is what? Dou z by dou y is equal to dou y of 1 by y, that is equal to minus 1 by y squared. This is what minus 1 by y squared. Therefore, we get this result, namely when I do the simplification, x cubed divided by x squared plus y squared. See, do all the simplification here. You will get x cubed by x squared plus y squared minus 2y into tan minus 1 of x by y. Minus into minus will make it as plus. See, this minus into minus will make it as plus, and do the simplification. You will get xy squared divided by a squared y squared plus x squared. So this is with respect to partially differentiating with respect to y. Now we will differentiate this. That means find the differentiation of this dou z by dou y partially with respect to x. That is why we write like this, dou x dou y. I have written here dou by dou x of this. When you do the dou by dou x, use the ordinary method of differentiation, treating y as a constant. That's all. Treat y as a constant, do the ordinary. If you apply the product rule and the quotient rule wherever it is required, and then arrive at the result. Nothing more than that. But keep in mind that here if you are going to differentiate with respect to x, treat y as a constant. Only that you must take care. So here you see that this is when you differentiate this x cubed, I apply the quotient rule. So x square plus y square into differentiation of x cubed minus x cubed into differentiation of x square plus y square with respect to x means treat y as a constant. That is why I am writing it as 2x divided by v square. That means x square plus y square whole square. That's all. Minus differentiation of this with respect to x means this 2y is a constant. Treat it as a constant. Then differentiation of this is 1 plus x square by y square into differentiation of x by y. Therefore 1 by y into x, you are going to differentiate only with respect to x, therefore 1 by y. Can you catch this? 1 by y into x, so 1 by y is treated as a constant, and then you are going to differentiate x with respect to itself, therefore you are getting it as 1 plus, see, plus, here I take this y square outside because it is a constant. For this differentiation, it is a constant. Then y square plus x square into differentiation of x with respect to itself is 1 minus x into, see, x into differentiation of y square plus x square. Differentiation of y square with respect to x is 0 because they are independent variables. And then with respect to x, 2x means x square means 2x whole divided by x square plus y square whole square. After that, mere simplification. You see that x square plus y square for these two, x square plus y square whole square is, here I am writing, see, just like this. It is the common term, so I am taking it outside. Rest of the, I multiply everything and keep, I multiply everything and keep, and this is 1 by x square plus y square whole square into, see, this plus this minus 2, see, this y square will go to the top, this y and this y will go off, giving you minus 2y square divided by x square plus y square. Then I will go for this simplification, see, 3x to the power of 4 minus 2x to the power of 4, 1x to the power of 4. 3x square y square minus 2x square y square is 1x square y square plus x square y square means plus 2x square y square plus y to the power of 4 is here. I am collecting all this, you see. I am rewriting simplification and rewriting this minus this 2y square divided by x square plus y square. But this is nothing but what? This is x square plus y square whole square, because x square plus y square whole square is x square plus 2x square y square plus y to the power of 4. X to the power of 4 plus 2x square y square plus y to the power of 4. So I will write in this place this minus 2y square divided by this. And here this is x square plus y square whole square, and bottom is also there. Therefore, both of them will get cancelled, giving you 1 minus 2y square divided by x square plus y square. Now you take this LCM, and this is x square plus y square minus 2y square. Therefore, these two will get cancelled, giving you what? X square minus y square divided by x square plus y square. So this is the result that we have. You see this. So we are able to prove this. So here you must understand that one thing that you must understand is, even if you find dou squared z by dou y dou x, you will arrive at the same result because commutativity holds good there. Okay. Now, so you see that I have done very simply. I have followed the rules of differentiation, product rule, quotient rule. When it is differentiation with respect to x, treat y as a constant partial derivative. Where with respect to x, treat y as a constant. If you are going to partial differentiate with respect to y, treat x as a constant. And tan minus 1 of x, know that differentiation of tan minus 1 of x, actually speaking, this is, see, the A more general way can be done. I will teach you that. We can go for a general way of tan minus 1 of tan, the differentiation of tan minus 1 of d by dx. D by dx of tan minus 1 of x. Even you can write tan minus 1 of ax. That also you can do. For which you will get a specific, a general result. So if you take a is equal to 1, you will get the result. That is the meaning of that. I will teach you that afterwards, how to get the differentiation of tan minus 1 of ax. Tan minus 1 of, here simply x, tan minus 1 of small a into x, where a is any arbitrary constant. So if you take a is equal to 1, you will get this result. That's the only thing. So know this, I applied this result here and I got the result. Nothing more. So this is a very simple problem. Now let me come to the second problem. What is this? E to the power of minus z divided by x square minus y square is equal to x minus y. We have to show that y dou z by dou x plus x dou z by dou y is equal to x square minus y square. Here also it is very simple, and know that if you properly understand mathematics, differentiation and integration, and if you can apply your mind properly and understanding the concept and applying the mind properly, you will see that doing any problem is not difficult. Okay. Now, so given this e to the power of minus z divided by x square minus y square, this is what is given. You take log on both sides. When you take log on both sides, know this, actually speaking, it is, if you have it as e to the power of x is equal to y, means this simply implies x. See, when you take log on both sides, log x log e to the base e, x log, actually this is the x log of e, this is equal to log y. So log of e to the base e is 1, therefore x is equal to log 1. So this is the actual meaning of it, and I apply that idea. See here, taking log on both sides, take log on both sides. Take log on both sides. So what is that you will get? Minus z divided by x square minus y square is equal to log of x minus y. So from this I get the value of z is equal to minus of this. Therefore I take this y squared, I reverse this. When you take this minus inside, it will be y squared minus x squared. So I small arithmetic I am doing. That is in the sense small manipulation here, sign manipulation. So z I get it to be what? It is, I take this my throat multiplied minus sign. So I am able to get z is equal to y squared minus x squared into log of x minus y. Take that as 1. Now mere small ordinary differentiation only. When you differentiate, now you are going to partially differentiate with respect to x, treat y as a constant, nothing more than that. So you see that this is, if you are going to do it, this is in the product form. See, this is, I will use product form. This is the one, I will use product form. That is differentiation of this you treat this as one function and treat this as another function. In this function, you see that you are going to differentiate with respect to x, therefore minus 2x into log of x minus y. Differentiation of u into v plus u into differentiation of v. That is the meaning of that. So here you see that minus 2x into log of x minus y minus y squared minus x squared into log of x, differentiation of log of x. See, differentiation of d by dx of log x is equal to 1 by x. Differentiation of log x is 1 by x. Differentiation of log x is 1 by x. So you see that here I differentiate this 1 by x minus y, but again x function has to be differentiated with respect to itself. But differentiation of x with respect to itself is 1. Therefore, I don't write it. So it is 1 by x minus y. So what is that you get? Dou z by dou x is equal to minus 2x log of x minus y plus y squared minus x squared into 1 by x minus y. And I say what is the result that I want? Y into dou z by dou x. So y into, you multiply throughout by y. So this is minus 2xy plus y into so much. Here what I do here is, see here, this is nothing but what? Y plus x into y minus x. I take this minus sign outside. So minus of y minus x. These two will go off, giving you minus y plus x. See, what I do here is that I take this minus sign outside, so this minus will be here. It will be y minus x. But this is y minus x into y plus x. A square minus b square is a plus b into a minus b. So this is nothing but y minus x into y plus x. So y minus x will go off, giving you y plus x. So a small arithmetic I am doing, nothing more. Algebraic simplification I do. That's all. So it is minus 2xy into log of x minus y minus y into y plus x. Now dou z by dou y. Partially differentiate this. See? 1. Take this one and dou z by dou y you find. Partially differentiate with respect to y. In which case what will happen here is that if you the x is treated as a constant, therefore 2y into log of x minus y plus y squared minus x squared into differentiation of log x is 1 by x. So 1 by x minus y. See? 1 by x minus y into differentiation of whatever is within the bracket. Differentiate x minus y with respect to y. But x is independent, so differentiation of 8 with respect to y is 0. So differentiation of minus y with respect to itself is minus 1. So I have written here minus 1. Then do the simplification as I have explained to you. So this is 2 and throughout multiply by x. So when you multiply this by x into dou z by dou y into 2xy into log of x minus y into x. Here again you see that I will write it as what? This one, see this minus 1 is here. When you take this x minus y, that is y minus x, then it will be minus into minus and make it as plus. So you will get y squared minus x squared divided by y minus x. So small algebra I am doing. So you see that you will get this y minus x and y minus x will go off because y squared minus x squared is y plus x into y minus x. So y minus x and y minus x will go off, leaving you with y plus x. Call this result as your b. Now what is your a plus b? A plus b is nothing but what? Y into dou z by dou x plus x into dou z by dou y. When you do the addition, so this you have to add this. See? This one and this one. You add. See, this is minus 2xy log of x minus y. This is plus. See, this is actually plus. So when you add these two, minus 2xy log of x minus y, this is plus 2xy, so these two will get cancelled. Leaving you with what? Minus y square, see I have written here, minus y square, minus xy, plus xy plus x square. So minus xy and my plus xy will go off, giving you x square minus y square. So this is the result that we have to prove and we have proved. So understand three concepts that when you are partially differentiating, treat one or other. That is, if you are going to partially differentiate with respect to y, treat x as a constant and vice versa. And tan minus 1 of x, you must that 1 by 1 plus x squared. So I have taught you how to prove that. I will teach you afterwards. And then log of x, differentiation of log of x is 1 by x. And these are the only important things that you must know. And you go for careful simplification of the expressions that you are getting or equations that you are getting, then arrive at the result. And product rule you use wherever product rule is applicable and wherever quotient rule is applicable, and do not give the wrong differentiation. If you are going to give a wrong differentiation, you will end up wrongly. So you have to be thorough with the differentiation of tan minus 1 of x, sin minus 1 of x, cos minus 1 of x, log of x, cos hx, sin hx. All these things you must be thorough. So when you know all these things, doing all these problems are very, very, very the simplest possible. Okay. So we shall see more problems in the coming days. Thank you.